Okay, let's have a look at some examples. So we have an alphabet A containing the symbols, the letters A and B, and we have a language L1 which consists all words beginning with an A and followed by 0 or more B's. So L1 would be a set containing the following words: A followed by 0 or more B's. So that means that the word containing only A is a good word. Then we can have A followed with one B, or A followed with more B's, etc. So the language L1 has words starting with an A and having 0, 1, 2, 3, etc. B's. Another language we can look at is language 2 that has one or more A's followed by one or more B's. So language L2 is a set containing a word one or more A's followed by one or more B's. So, for instance, these would be perfect good combinations. If we look at this language L2, then the minimum size word would be the word AB with a length of 2. Language L3 has one or more A's with the same numbers of B's, so that's a different language than the previous one. So if we look at L3, then we have at least one A, and if we stop at this one A, then we have to add exactly one B. If we start with two A's, we have to add two B's. A3, B3, etc. So the minimum size word in L3 is AB, and all words will have an even length. L4 consists of all words with exactly one A. So now we don't care where the A is located. So it could be in the beginning, somewhere in the middle, in the end. We really don't care, as long as there's exactly one A in it. So if we look at language L4, so again, we could have a word only with one A. But we could also have B square A B to the power of 3, or B5A, or AB3. So all sorts of possibilities as long as the letter A only appears and exactly once appears in the word. Then the last one, language L5, consists of all words beginning with AB. So L5 is a set containing words beginning with AB. Nothing more, so we can already end. But we could also put in some A's, some B's, some A's again, or only B's, or so the only real thing we know about these words are it starts with AB. All these languages are subsets of A star. With these languages, as we know they're sets, we can take all the normal operations as we already did with sets. So we can look at an intersection, a complement, a union, etc. So everything we could do with sets, we can also do with languages because they're just specific sets. There's one extra operation we can do with languages, and that is the concatenation operation. So if we look at a concatenation, then LM is a concatenation of two sets where we have a concatenation of two words, the first one coming from the first set, so from this L, and the second one coming from the second set, so from M. So, for instance, if we have L1 being A, B square, and L2 being A square, AB, B square, then we could describe L1, L2 as a concatenation of the words coming from L1 and L2. We have to start with something from L1 and fill it up, concatenate it with something from L2. So these would all be perfect combinations. and the last one. We can also concatenate a set with itself, and then we have L to the power of 2 or L to the power of 3, etc. If we look at L to the power of 0, again, that's a specific set. So we concatenate with words from L, but if we did L1, that would mean we take only one word, but now L0 means we take no words. So L0 will result in only a set with only one word, and that would be the empty word. So mind, L0 is not empty. L0 has one word, and that word is empty. So one specific element we'd still like to tell you, and that is L star. And L star is known as the clean closure, which is the combination, the union of all possible powers of the languages. So it starts from L0, being the set with the empty word in there, united with the language itself, united with the language which contains concatenations of words from L, but only twice, etc. So L star is the clean closure. If we look at lambda, would lambda be an element of L star? And yes, of course it would, because we just said that also L0 is part of L star, and the empty word is the element of L0. So if we look at the language L, and we would say, okay, let's look at L star, then L star would contain all possible concatenations from the first word from L with the second word from L. So, for instance, A star, A star, A star combined with BC, or BC, A star, or BC, BC. And then again, if we would look at L3, that means we would have L2 and then just add for all possible elements one of the elements from L again. So that would be A2, 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 BC, etc. So for all these four elements of L to the power of 2, we would make two more combinations with either A square or BC. Okay, let's look at this exercise. So we have a word U, which is AAABA, and we have a word W, which is AABA. So what is UV? Let's look at it. So UW would be a concatenation of U, which is AAABA, concatenated with A square BA. Okay, if we look at WU, then we know that concatenation is not commutative, so we will get a different word. So that would be A square, BA, AAA, BA, which is definitely different. If we look at the length of U, so the length of the word U, that would be 5. So AAA, BA. The length of WW would be twice the length of W, so that would be 2 times 4, which would be 8. If we look at the concatenation of languages, and let's do the first one, LK would give us a word from L combined with a word from K. And now we're quite lucky because L only has one word and K only has one word. So LKK again is just a language with one simple word, the concatenation of A and BB. If we look at L square K, then we have more possibilities. And so we choose, more possibilities. We again choose one from L, which is only A. We choose again 1 from L, which is only A. And then we have BB. So again, a set with one word. So they make life really easy for us. So if you have a set, a language with only one word, then concatenation with another language with only one word still remains being one word. You can imagine that if we have languages with a lot of words, then this will grow exponential. If we look at, for instance, the language L, K star, and that would mean we have A, and then we can take K star, so we could do the empty word, or we could do A, B, B, or A, B4, etc. So now, because of the clean closure, we have an enormous amount of words which we have to combine with the words in L. Okay, let's look at this exercise. So L being 0, 1, 1, 0 to the power of 3. So if we look at some examples, that would be 0, 1, 0, 1, 0, 1. I have to choose 3 times, and I just chosen the first one 3 times. But I can also do the first one, choose the second one, and choose the first one again. Or I will choose the second one 3 times, etc. The second one would, for instance, have, okay, A star. What does that mean? Well, in fact, it just says you can choose 0 times or 1 time or 2 times or 3 times from this language with only the word A in it. So let's choose for the first time. I pick 2 times A. Then I have to add BA. There is, in fact, you should read a 1 here. And then I have to choose twice from the third one. Well, there's only one option, so I have to pick B twice. So this would be an option, but I could also just omit the first one and say, okay, let's start with BA, BB. Or I could do A3, BA, BB, etc. And then the last one, we start with a choice. So remember, you have to put a 1 there symbolically. So we can choose from ABA or BB. So we have, for instance, ABA. And then the second part means I have to choose 3 times from 0 or 1. So let's do 0, 0, 0. Or we could do BB and then 0, 1, 0. Or we could do BB, 1, 1, 1, etc.